Alright, let's get started. So today we're going to do some flow fields. So first thing first, we will need a 2D grid, right? So let's start by creating a 2D grid. Right now our canvas is 600 by 600. I don't want to create a grid of 600 by 600 because we're gonna have like vectors. So let's think of it as little arrows in there. So we're gonna have arrows in every square, let's say, of that grid. And I don't want to calculate for 600 by 600 squares for every arrows and so on. So we're going to scale it down. So we need some kind of scale, right? Let's call it SCL, just for sure. It doesn't matter what you call it. You can call it scale. So let's say we divide it by 20. So scale would be divided by 20. Okay, so our grid now. Grid, right? So the grid. Let me think about it. So we will just start with just an empty array. We can just start with undefined, to be honest. So let's just not assign it right away, and we'll do it right here. So the first thing first, we need to divide our width by 600 to get the columns, the amount of columns, and then the height also to get the amount of rows. So let's start this. Columns. So it's going to be the width divided by the scale, and I'm going to floor this just because sometimes, or we could actually seal it just to make sure that we're keeping, like, we're showing up to the edge and more if we needed. If I were to floor this, I would probably, most of the time, if it doesn't divide and give zeros at the end, like if there's any rest on the division, it's going to leave like one column empty, or somewhat one column. So I'm going to just seal it, and I'm going to do the same for the rows, right? So the rows, it's going to be sealed of the height divided by the scale. Same thing. All right. And we need, for this, we will populate our grid variable here with arrays of arrays, right? So let me just do this. We can do it in a lot of ways. For right now, I'm just going to do it a generic way. Sorry. And we can always just change it as we go on. So the calls, let's just call it I and J just for right now. It doesn't matter. Do I want to preset the grid to some array? Let's do it. It doesn't really matter. That's fine. So okay. So let's say I is equal to 0. I is less than the calls. I plus plus, there we go. Let's do the same. For let j is equal to 0, j is less than the rows, j plus plus, there we go. We have it for the rows now, and let's now populate the grid, right? So here, whenever we're doing the loop for the columns, we need to add a new array into the grid, right? So grid, and then add the index of the column. We're gonna say it's an array, right? And then here, I mean, we're gonna want to populate it with some kind of vector, right? Let's just create a vector, and yeah, let's do that. So let me think about it. So we just need the grid at index of the column, and then it's also an array, so we go index of the row, and then we say, let's say it's going to be equal to, give me a moment, I just need to verify online, but we'll check this out. All right, so p5.js, there you go, and then let's go into references, and let's search for vector, There you go, create vector. Okay, cool, that's why I wanted it. It's just because it's a bit different for processing, so I wasn't sure. Okay, great. So I believe there is also random 2D or something like this, right? Let's see. Let's just create random vectors for the moment. Angles are equal. Okay, from angle random 2D. Create a new random 2D unit vector with a random heading. That's great. That's what I want for right now. So, alright. So let's create a vector dot random 2D, right? So let's do this. And in draw, well, for the moment, let's just not do anything in draw. I'll do it in setup for the moment. Okay. Oh, and we'll set our background right here in the end. Let's do it white or close to white, and then let's draw each of the vector with a line. So we'll have our grid, and we'll have all of the vectors as arrows, or in our case it's going to be lines in there, and let's just draw them. So we're gonna go over loop again, like go over every cells or every vector in our grid again. And what we're going to do, this we don't need anymore, not for this part. And this, let me just keep this just because we're going to use it. And let's call this const vector. Sure, that's fine. So now I need to calculate the x and y, well, the position of that specific vector, right, in the grid, because the I and the j are based on scale, right? So we need to multiply the I and j by the scale. So we're gonna have, we said that I would be the columns, right? So it's going to be x, and j is going to be the rows, right? The y axis. So const x is going to be I times the scale, and const y is going to be j times the scale as well. Great. Now we have our x and y. So let's draw our line. So let's first set the stroke to be, I don't know, some well, black. And let's also set the stroke weight to 2, just so that we can see it better. Stroke weight to 2. There we go. Okay. And let's over here, let's draw a line that goes from x, y to, it's going to be x plus vector dot x and y plus vector dot y. There you go. If we save this, we should normally see some lines. Oh yeah, I mean those lines are pretty small. I'm pretty sure they might be there, but I'm not seeing those. Let's open the dev tools, right? So let's see. Do we have any errors? Yes. Vector is not defined. Okay, that's fine. That's fine. Let me see. Let me see the reference. P5 dot vector. Do I need to call P5 dot? Let's see. We might have to. It's possible. Okay. So let's close this and let's do P5 dot vector. There you go. Awesome. And let's maybe multiply the vector by 2, right? Just because otherwise the lines are going, because right now the vector is like 1. The length of the vector is 1, but we want it maybe to show a bit like better. So we're gonna say, I don't know, we're gonna say multiply that by I don't know, like 2. Mult by 2. There you go. Now the lines are a bit longer. Let's multiply it by 5. There you go. Now that's easier to see. Great. So we have some random lines in our grid. That's cool. Now, I would possibly like to offset all of those by half of the scale, right? Because I don't want them to start on the edges I want them to start like, because right now they are starting, each line are starting at the corner edge, top left edge of their specific like grid cell. But I want them to start in the middle of those cells. So what we could do is possibly just add on to the vector itself the starting position of the line. Sorry. So the starting xy value of that line could be added the scale divided by 2, right? So let's try it out. Scale divided by 2. Let's do that 2 times for the x and for the y. Save this. Now, yeah, now this seems to be starting. Let's see if we refresh a couple of times. I believe it is starting from the middle of each cells. Let's draw the grid actually, right? So that we can see it properly. So to draw that grid, we'll just draw lines across. And let's remove the, well, let's do mode 2 for the moment, just so that they're a bit smaller. I mean, it's pretty random-ish. I mean, it's supposed to be. Alright, anyway. Should I draw those? I'm not going to bother drawing the actual grid in the end. Yeah. So, let me see. There you go. Okay, give me just a second. I'm going to make this a bit easier for you guys to see. Okay, good. Yeah, that's fine. Awesome. Even a little bit less. Now this is the full thing. Okay, great. Yeah, sorry, just trying this out. Okay, great, perfect. So, yeah, now let's think about it. So we need some points, right? We need to drop some points on there, some particles, some whatever you want to call it. And those points that are going to be dropped on the grid need to follow the closest or the nearest cell adjacent to it, right? So how do we get the adjacent, the closest adjacent cell, right? So we're gonna have some xy value, and I will want to do divided. I'm going to need to divide. So okay, let me see here. So we're gonna have some. Let's do it for one. So a point, which will have some xy, and those xy are going to be based on the canvas, like the width and height. So right. So based on it width and height, right? The issue here, right, is that we need it to be based on the scale, not the width and height. So we are going to need to divide the x and y by the scale, and then that will be based on the same base as I and j if we were, well, on the length of the number of columns and the number of rows, right? So number of columns, number of rows. And we're going to floor this value. We could actually seal it, seal the value. This is going to give us some I and some j, right? Based on x and y. So let's just, first thing first, let's create an array of points, right? So const points, which is going to be an empty array to start with. And for the moment, let's just use regular JavaScript object. We could just create a class, but we might want to do this later on. For right now, I just want to get the basic principle done. So over here, let's create the points. Create, well, let's not write it out. It doesn't matter. for let I is equal to 0, I is less than, and I think I'll want it as a variable, so let's just do const point amount, and let's do like 100 for right now. It's probably going to be more than that in the end, but for right now let's just do this point amount. There we go. And then I plus plus for every point. Well, for all of the point that we want to create, we're just going to say points index I is going to be equal to just an object like we said, and then we're going to give it like some random width and height. So x is going to be, or we could just use like create vector, right? It already has everything we need. So let's do that. Create vector. Great, awesome. And we want to pass it width divided by 2 and height divided by 2, right? So some random, no, sorry. Random, there we go, width and random height. Yeah, sorry, not sure what I was thinking there, but hey, we get there in the end. Okay, cool. So we've got our random points for the moment, right? So let's also draw those points. I know I'm going to do this in a lot of loops, but we'll refactor it just afterwards, where we're going to try to concise everything in like 1 or 2 loops, just so that we don't iterate for nothing, right? Because just iterating is not the best thing in the world. So let's just draw those points. And let's make the background a bit grayer, so maybe 200 would be fine. Okay, sure. Maybe even like 180 should be good enough. Yep, 180 is fine for me. And then points, let's draw a point actually at point dot x and the y. Okay, cool. And let's do stroke 255. So let's draw it white, and stroke weight, let's do 5. Yeah, sure. There we go. We now see our points, right? And we want to find the closest or the nearest the nearest line for each point. So in here we're going to try and find, like, for example, this one. It should technically be this line that is like on top of it. So let's do that. So let's do exactly what we wrote here. So for, again, a lot of loops, not necessarily the best way to do it, but we're getting there. I might just go back to this for right now. That's fine. Yeah. And then points dot length. There we go. Just, it doesn't matter. We can change it afterwards. That's fine. Okay, great. So the actual const I is going to be, so this would be like the column index, right, that we want. So it's going to be, we said, oh, and we might want to replace this, I don't know, K could be a good letter. K, sure, K, all right. So it's going to be points index K dot X, divide this by the scale, and we said to seal this up, right? So seal. Great. We might want to floor it. I'm not sure exactly, but we'll see. I mean, it's not a big change either way. And J, it's for the Y. And it's the same thing. And then Let's call this cell. So the cell that we want will be the grid at I, j. Awesome. There's an error, it seems. Let's see what it is. So can read property of undefined reading 19. What I'm thinking right now is that here, let's try the floor. Okay, so we'll use the floor instead, sorry. There we go. So now the seal, floor, there, cool, awesome. Let's refresh a couple of times, just making sure. Yeah, everything seems good, cool, all right. Now, we want the points to move, right? So we want them to have velocity of some sort, some acceleration. What else? What else? Velocity, acceleration, position. Yeah, okay, cool. All right, so let's create like a point class or something like this. It doesn't need to be called point, but let's call it point for right now, right? So let's create a class, right? Yeah, let's remove the background completely for now. Class point. You could call this particle, you could call this whatever you want, right? It doesn't really matter. Okay, so for the class point, we're gonna have a constructor. Awesome. For right now, let's just not put anything in there. We're going to fill it out, but I want a static method to just create those points. It's going to be easier for me. Or we could just call it new, but let's call it like init, and let's give it a position, right? Position, and this position will be like p5 vector, right? So p5 dot vector. Awesome, great, cool. So we're gonna just do return new point with the position. It's the same, it's going to be the same as the constructor. That's what I want. That's you could do it all with the constructor, but I don't know, I like it like this. All right, position. Whoa, not like that. Position. There you go. Okay. So this dot position is going to be equal to position. And I'm going to make copy of position just because I believe copy is something. Let's see. Copy. There you go. Yeah, copy. Awesome. Whoa. Okay, there you go. Let me do this so that I can just, yeah, okay, great. So we have the position. We'll need some velocity. And we can just do a new random vector. Or we could just say like we could just have it be like starting at 0, 0, so it doesn't have any velocities to start with, and do the same for the acceleration. I believe it is like this. Acceleration, I'm not English speaker, so acceleration, great, cool. And it's going to be pretty much the same as the velocity, cool. So we have the position, velocity, acceleration. Great. So now we want it to move. So it's Okay, right. So we need to make it move, right? So let's have a function that is going to be called apply force. So we need to apply the force of the specific arrows onto every of those points. In our case, we're going to receive a vector, which is going to be the arrow itself. So we're going to receive some force, which is going to be, like we said, another p5.vector object. Great. And this is just going to be added to the acceleration. Great. And we also will need, so this, okay, that's cool, but it doesn't make it move, right? We need to some kind of update function, right? So we need to update the particle in our configuration. So let's call it update as well. It doesn't receive any argument. It's just going to be updating the particle based on its acceleration, right? So we need to update the velocity based on the acceleration. So cool. And we will need to update the position based on the velocity. Okay, cool. Great. And we also need to reset the acceleration. Multiply by 0, I guess. No, multiplying by 0 gives us 0. Cool. Okay, so we have our particle right now. Well, our point, whatever we want to call it. Cool. So I need to replace all of my points from the array into a point, actual instance of the point class, right? So let's start with that. Yeah. Okay, let's go over where we create those. Here, right? So we need point now dot init. That's the method I've chosen, but it doesn't matter. You can choose whatever else you want. It's going to take whatever was there previously. Cool, cool, cool. And it's going to be point dot position dot x and point dot position dot y. There we go. Same thing here. There you go. We have the exact same thing that we had before. Though now let's do adding of the so let's get back our draw function. Because right now it's only going to move once, we're not even going to see it. So yeah. Cool. Let's cut all of this out. Let's add it in draw. Now our points are getting redrawn every time. And also we are currently able to find the cell itself. So let's for that specific point, right? So for points, index k, let's apply force. And we're going to apply the force from the cell. Since the cell is a vector in itself, right? Like we created from here, it's fine that we use apply force, since force is also supposed to be taking in a p5 vector. Cool. So now we're applying the force, but we're not moving the point because we need to call update on it. So it's called dot update. And let's see it now. So it is moving up until some point, right? So at sometime it's stopping. Why is that though? I'm not certain, to be honest. Let's see. Do we get any errors? First thing first. We do. All right. So it seems, from what I understand of this, it's getting outside of the grid. Then when it's trying to find itself, it's not able to, right? This probability reading of 20, this is probably here, right? Index I, index J. This is probably the issue, and we can click on it and see it, right? Yeah, index I, index J, right? Let's go back to console. Yeah, so what's the issue with this? Like we said, the cell is getting out, well, not the cell, but the points are getting outside of the grid, and so it cannot find the closest one since it's outside of it. So what we could do is I'm thinking of two options right now. We could have every point going outside of the grid, so or outside of the canvas, just pop out on the other side, or we could completely remove it or recreate the point at some random location within the grid itself. I'm going to go for the first option for right now. So just making the point appear on the other side, or from the top to the bottom, so on and so forth, right? So to do this, I will probably want to have this in here, right? Because we're changing the position of it. So I don't want to change it from like anywhere else other than within the point itself. We can have a method called edges, maybe edge, doesn't matter. And then we can check if point is not outside of that edge, right? So yeah, okay, let's do this. So we know it's from 0 to width and from 0 to height. So if the position dot x is smaller than 0, then we're going to say the position dot x should be equal to the width. Else if the position dot x, same thing, is greater than the width, then we're going to set this dot position dot x to 0. Awesome. And we're basically going to do the same thing, but for the height, or for the x-axis, the y-axis. There we go. Y smaller than 0, then it's going to be height, and then y is greater than the height, then it's going to be 0. Awesome. Okay, so now in here, in the draw function, where do we want to call this edge function? I'm thinking before doing this, right? Before finding the I and the J. Otherwise, we won't be able to. So here, I'm going to do the point. Dot check dot edges. Okay, awesome. Now, what's the issue? Now, let's clear this. Let's restart. Okay, so there's still an issue, right? What is that specific issue? Can't read property of undefined reading 10. It's the same place, right? Okay. I want to do one small trick and see if it works. I mean, it may not be the solution, but for right now, that's what I want to try. So what I want to try is actually over here, right? Calls and the rows. I want to do one more on those, right? So I'm just cheating a little bit. +1 and +1 as well. Just There you go. Now we've cheated, but it is working, right? And it was going to the edge and it was like not finding it, but now it's finding it. That's cool. Because, yeah, I mean, sure. I mean, it's a trick, right? It's not the actual solution, but good enough for me. Now, let's redraw the background. And maybe those are going a bit fast, right? They're accelerating really quickly. Maybe we could add some dampening effect on it, right? So maybe the update, within the update method, we can have some dampening effect on this. Think about it. Let's say that the velocity is dampened, so maybe multiplied by a constant value of like 0.8 or something like that, right? So it would slow down, but it accelerates with the acceleration. So maybe 0.8 is a bit too much. Let's do 9.5. Looks better. Let's redraw the background now. Let's draw it black, right? So that we can see it properly. So right now we just have some particles randomly moving around because our vectors are pretty much random, right? That's okay. That's what we said we wanted, right? So now, one thing. I know why it's moving so fast. Yeah, sure. It's because I'm doing a multiplying here. There you go. Now it's better. Cool. So it's moving randomly, right? We need to update this. We don't want it to be moving randomly like this. So what do we actually want? We want a flow field, right? We want some kind of wave stuff. Let's do this. So for that, basically going to use I'm going to comment out the draw function for the moment. We can come back to it. Okay, great. And that is just because I want to see those lines, right? These lines, right? Cool. So I don't want to create random vector, but I want to create a vector based on noise, right? So if we go over here, we search for noise. I want this function over here, noise. Great. See, we have a particle moving randomly. It's not based on a, it's not based on a specific flow field of some kind, but it's noise, and it's what we're going to use. See, this is great. Yeah, that's exactly what I want, actually. So, let me think about it. So I'm getting one value so basically the noise function returns one value, and I want maybe the angle based on that value. So yeah, I guess we could do that, right? So if we take a look back at the vector, I know there is, there you go, from angle here. So we can create based on an angle. So right, see, we have some arrows. And angle, desired angle in radian. So we need an angle from 0 to 2 pi. So let me go back to the noise function and let's scroll down a bit. Doesn't tell us what it's going to return, but I'm pretty sure it's a number between 0 and 1, right? So hear me out, let's do this. So we need some, we already have our grid for that, so that's good. And then let's use their noise. We can change it later on, doesn't matter. And then noise scale. Okay, cool. Whoa, not this. Okay, cool. So let's have our noise level and scale here. Have them as const. Great. And over here, let's do const nx is equal to noise scale, I believe. What was it? Yeah, the noise scale times the x, or the I in this case, and ny is equal to the noise scale again times j, and then const angle, it's going to be noise, well, angle is going to be equal to mapping the noise, which is going to go with an x and y from 0 to 1, and we want the angle to go from 0 to 2 pi, right? Because it's a radian angle. And then we can just do vector dot from angle, right? There you go. With that, we can pass in the angle. Great. And now, I mean, it's not showing much. Noise level, we don't really need this. Noise scale, let me try 1. I mean, I see it a bit. It's not amazing, but it is moving a tiny bit. Maybe we want to gap these a bit more, so maybe times 3, right? Maybe times 4. Okay, and let's see what kind of values do we get for this. Let's call this value, it doesn't matter. Oh, wait, I just am not thinking properly today, but this needs to be done also. Whoa. this needs to be done also for these. Yeah. That makes more sense. I mean, it just look like points for right now, but let me do like maybe times 2 on these, or even times 3 on these. Whoa. There you go. We can see they're pretty random. So let's try back one. Too much fluctuation again. 1.01. Let's try what they had. A bit too little, I would say. Oh, this looks good. I mean, it's a bit difficult to see right now, but let's see. Let's add back our points. Yeah. See, they're moving based on the, if I refresh, it's going to be a different field, right? Pretty quick. We have that. So now, 47 minutes in. We already have some pretty functional flow field. It's not great because it doesn't change, right, on time, right? Like I would like for the flow to actually change. So let me first do something. Let me, in the draw function, let me comment out everything that has to do with the points. Let's not care about the points right now. And let's instead draw, let's do like a white background, or let's keep the black background, and I'm just going to want to draw the actual field of flows in here, just to see it. This stroke 255, let's draw them white. Why is it not working? Let's see. Calls is not defined, right? Makes sense, because we haven't done this. So let's get both of these values out over here, and let's have them be not defined yet. There we go, and let's remove this from here. Awesome, great. So right now, I mean, it's the same thing as before, and I might even, let's just do a variable real quick. I'm going to remove it eventually, just mode, and let's say 5, just so I can change it easily. There we go. All right, now we can see a fill, right? You can see some kind of shape, something, right? That's great. What I want is for that shape to change based on the frames or the time that has gone through something, right? So I'm going to make it change on based on the frame rate, not the frame rate, but the actual frames that have been done. So what we can do for this is basically over where we get the noise. So actually we will have to recreate, maybe not recreate the arrays, but recreate the cells on every render, right? Because we wanted to move every frame. So sadly, I'm going to copy this again. Whoa, no, there we go. I might just take this, place it in here, and then do this. That's fine, but this is also not going to change it, right? I mean, personally, I'm not seeing it change. So to make it change, make it move through time, we need to update the noise here. So let's call this const nt for time, right? Noise time. So it's going to use the noise scale again. but this time we're going to time it based on the frame count value. And this is just the amount of frame that has passed, that have been drawn, right? So here, let's add this in here, let's save and let's see it move. Right, it's moving, awesome. It's moving way too fast though, way too fast. So we could keep some other variables or something. Let me try just something out. Yeah, let's not use the frame count. Instead, this looks like some kind of clap in the wind or something. It's pretty strong wind, but hey. Let me keep another variable that will increment a little bit smaller than 1 every time. So, what variable do we want? Maybe we could call it time or something like let time equal to 0 to start with. And then we could do something like time plus equals, and then we could call this let or const increment. And this could be like 0.1. Let's try that to start with. There, here. And then instead of all of this, let's just do time. Still moving relatively fast. So let's also multiply it by this. It's fine by me. Time, there we go. Oh, this is a lot better. This is moving much slower. Let's draw the points now. Let's draw the line a little bit less thick. So it's following the flow field, which is moving. It's still going pretty fast, I would have to say. Maybe before, well, so here, right? We could multiply this by like, I don't know, 0.3, something like that. It's moving a lot much slower. That's great. That's what I want. The flow field looks good. Now let's try to draw like a trail of some sort. So to do that, let's just not draw over here this. Let's just not draw these, the background, the field itself. Let's remove this as well. Well, yeah, I don't need it. Save. Let's stop drawing the background. We can draw it once it's black over here. Great, awesome. Let's make the lines a little less thick, maybe like 1. Great. Right now they are drawn as points. So sure, it's showing. But what I want to do is draw them as line. And what I can do for that is basically have the previous position. Let's call it previous. It's fine. And to start with, it's going to be the position itself. I mean, what can I do? And then every time we update, we're going to set this dot previous to be equal to this dot, oh, and before, whoa. Before we do the update, basically. Before we do the update, it's going to be equal to this dot position, dot copy, important. I don't want it to modify itself. Okay, great. And then in the draw here, where we draw our points, let's not draw a point, but instead of a point, let's draw a line that goes from one point, I mean, it doesn't matter, but let's do previous. Well, before I do that, I'm just going to copy this whole thing, add it at the end. It's going to be previous. Whoa. And then previous. Now these are lines. And what I want also is maybe not draw, maybe have some alpha, right? There you go. So that's pretty much it for me today. Feel free to play with the code on GitHub, add some colors, do whatever you want with it. It's been fun. All right, thank you. See you in the next one.